Welcome to the Wednesday webinar by PDSVISION. This is the Digital Thread series. This is the second in our series. The initial series was dealing with industrial design. This one is now dealing with engineering design. My name is Michael Wimberly, and I will be presenting today. So in this webinar, we're going to go through and, of course, give an overview of PDSVISION. We're going to go through and talk about what digital thread is, and then, of course, go through and talk about how digital thread is woven into the engineering design stage from the things that were done in the previous webinar from the industrial design stage. So once again, my name is Michael Wimberly. I have been with PDSVISION over 9 years now. I have over 20 years of experience with PTC products and am a certified trainer and Windchill implementer of Creo and Windchill. As far as PDSVISION, we are, of course, formerly Boundary Systems. As of the 1st of 2022, we have now become PDSVISION US. We are still a technology leader with the partnership with PDSVISION. We are the first global reseller and preferred service provider for PTC, software solution developer and design manufacturing. Our capabilities, consulting, implementation services, professional training, cloud, as well as help desk. Now, a little bit of history, just real briefly, of Boundary Systems and PDSVISION. Boundary Systems was founded in 2006. PDSVISION Group was founded in 2008. We became a Windchill partner for PTC in 2009. We also became had a global presence starting in 2014 into South Africa. And 2018 is when we became part of the PDSVISION Group. And then once again, with PDSVISION, they've also acquired additional VARs, NET being one of them in Germany in 2020. And as I stated, in 2022, we officially changed our name over to PDSVISION from Boundary Systems. We're the same company, give you the same quality information or services that we've always provided. We just now have a bigger footprint that we can go through and assist you with. We also partner with additional companies such as PDC, of course, Tacton, Modex 3D, Xformation, eTraj, Sigmaxim, ZWCAD, and on. So we deal with things from rendering, we deal with mode design, mode flow, we license monitoring, 2D software, or even if there's an application that may not exist at the moment, we have partnerships with companies such as an ITI and some of the services that we have because of our global partnership, our global presence, that we can go through and help develop some of those applications that are necessary. So now we're going to go through and begin our digital thread presentation.
Digital Thread provides a comprehensive approach to the application of PTC software suite relative to the intersection of the individual applications and where they're utilized in the manufacturing process. This philosophy leads to reduced time to market, reduced downtime in production, reduced costs, and an increase in overall manufacturing efficiency. In this series, we aim to illustrate the importance of the interconnectivity of the digital thread by showing a typical production of a car, but the concepts can be applied to whatever product you produce at your organization.
So if you all remember the digital thread from last time, we began our series with this car. Now we're going to build up on that. It was from an industrial design. Now we're going from a mechanical design. What was sent was now a change request to go through and review the design of that car, the updates that were done. So that was sent to me to go on and review that, and that's what we're basically going to do. At this point, we are going to go through and look at the changes, both in a JPEG, which is what we're looking at here, so we can see the difference between before and after. So we can see the changes that were actually done, And then we're going to physically go look at the part as well. And we're going to do that inside of Creo View. This part is inside of our change request area, but now we're going to go and open it up from there and view the changes. So you can see in the physical part in Creo View that we can actually go through and see the changes that were done. So the back area of that car are the ones that were actually updated for us. From what I'm seeing, everything looks fine. So what we're going to do at this point is simply go back and now approve this. Now, once we approve this, the other thing that we're going to go and need to do is now begin to develop the work. Who's going to do the work? So that's what we're looking at here. The first is let's approve it. The next part is creating a change notice, which is now going to go through and define what work needs to be done to attach the body or update any of the other objects. So what we're going to do on this one, first task is going to be updating the frame to attach the body to the frame and make the appropriate adjustments. Then go through and update the driver's seat and then create the drawings. That is sequential. So after the frame is done, the seat will be done, and then the drawings will be done. Now, in the change task, we have the initial files that are associated, which is the frame assembly. In the lower half, we're going to go through and develop or talk about the files that were actually changed. Once we completed that change notice, I now get a notice to go through and now basically complete my task, which is going in and updating the first task being the frame. I go through and look up the frame. The first thing I need to do is understand that, yes, I am changing the frame, but I'm actually going to be working on the entire car. So instead of just downloading the frame from Windchill, I'm actually downloading the entire car from Windchill, because I am going to be working on the frame for my first task, and then I'm going to go be working on the seat for my second task. So as that is now downloading to my workspace, once it's in my workspace, I am going to open up that file inside of Creo, and then I can begin my work. So there's the car. Once again, if you've seen the previous webinar, that is where we left off. If you haven't, definitely go look at it from an industrial design standpoint. For this one, as we mentioned, we're now going to go through and actually develop the mounting of the body to the back frame. Once that is complete, we're also going to go through, as my second task, is update the actual seat. So I'm going to go through and now bring up the frame assembly. In the frame assembly, I've copied surfaces from that body so I know where it actually mounts, as well as from the one end and where the actual body frame, the car body is actually located. So I can move back the frame appropriately, give myself space to go through and add my mounting surfaces and then actual mounting pads on the actual car itself. So I've gone through and developed that. I've reduced the size or adjusted the size of the frames, and then created my mounting surface on the frames, but giving myself enough space to develop the padding that goes on the inside of the car body. So when I go back into the car body, you can see that I've developed both. So there is the mounting surface on the inside of the car body, and then the actual frame mounted to that. Now, that task at this point will be considered completed. So I'll need to go through and now go to that task and say complete. But I also need to add the files that I've changed in the resulting area so that I can go through and document what has changed. And now you can see in the lower section, I've added all the frame parts as well as an updated version of the car body as well. In the actual task itself, there is a resulting tab that will also show the information, but now from that change task, I'm going to go in and simply complete this task. Once I go in and complete this task, I now get my second task, which is now simply updating the driver's seat. So now when I go through and I update or select on that, I now can go through and begin to work on the seat. So we can see here, there is the seat in the car. Now, currently that seat is inside of this sub-assembly, but we want this seat to be a little bit more modular. We don't want to have to change the sub-assembly every time we go through and want to change out the seat. So if we're looking at the actual BOM structure in Windchill, what we will see is that, yes, listed underneath that assembly is that car seat. So we see the bracket seat assembly that is listed inside of there. We need to change that so it is no longer a part of that assembly. Because this is Creo and we're simply working in that file, we simply need to go through and take that bracket assembly and delete it out. Once we go through and delete it, it is now removed from that assembly. When we go back to the top level assembly, we can of course see that it's removed from there, but we want to assemble it at the top level. So we're only affecting the top level assembly when we go through assembling in. So now we can see that the car seat is there and it is currently at the top level versus being at that lower subassembly level. So there are some BOM restructuring that we're doing here, but we're doing this directly through Creo. And as you can see, once I go through and refresh this window, that seat is no longer a part of that subassembly. So now that subassembly has changed and that will become one of those resulting items inside of my change task. Now, what we were actually doing with the seat was we were going to go through and actually update the seat to go in and thicken up the value of that. So what we're going to do is now open up the seat itself and now begin to work on the actual seat body itself. So we're going to go through and select on the seat. We're still in the subassembly, but we want to go directly into that part to go through and start to manipulate it. So what we want to do is we want to take this seat and we want to make it a thickness of 10. It is currently a thickness of 5. Now, once we go through and we change it, we see it turns red. Red is not good. It lets us know that it could not go through and create the seat at that thickness. Now, why? We don't know initially, but we're going to go through and now evaluate this through several analysis tools to go through and figure it out. First, we're going to go in and actually specify or going to see an offset analysis from the actual geometry. And as you can see, when it does that, it goes in and creates this mesh that goes in and shows us the offset. Anywhere that the mesh is tight, we want to go through and look at. But by viewing it, everything at this point seems to be okay. So let's update it to the value that we really want, which is 10. Now, currently, as I said, in most of it, everything still looks okay. But when we come up here to the top, we can see that now it begins to overlap. So that contour at the top is an issue. Now, another tool that we can use, which is not an analysis tool directly, but it's a surfacing type tool, is an offset. With the offset, we can actually see graphically the actual surfaces that are not offsetting. So although it shows that intersection up there, you know, when I go in and update it to 10, it shows quite a bit up at the top that is not actually being offset appropriately. So what we need to do is we need to go through and change that contour in our freestyle to go through and update this appropriately. So we're going to go through and make a few adjustments up here at the top to go in and make sure that everything is fine. We've made those adjustments. And now at this point, we want to go through and validate that it works. Now, this may be a continuous thing until you get your geometry correct. So with this one, I have done this a couple of times, and now I can see that when I go in and put that in there and offset it at 10, there's no issue. So I may have gone in and tweaked it a little bit before this end result, but this one works properly. And once again, I'll go back into my offset and offset that geometry. And the same thing here, when I change this to 10, I can now see that all the geometry at the top is offset appropriately as well. So what that tells me is that now my seat contours are appropriate, where I can go through and actually offset my geometry to a thickness of 10. As you see here, it is 10 and everything is thickened appropriately. So with this, once again, we just want to make sure that when we are designing our seat, that we can go through and make that. Now, designing in free form is exactly what it sounds like. It's free form, so it's not dimensionally driven. It's actually more aesthetic. So it's an industrial design tool, but we have to make it, so that's where our analysis tools come in as well. So we want to make sure that the geometry that is designed in the freestyle can appropriately be designed. Now, what we're also just want to make sure of is that when we go through and mount this, I haven't added any mounting hardware yet, but that the brackets are positioned appropriately, and that with the positioning of the brackets and the seat, it fits in the car properly. And as you can see there is proper ample spacing on either side of those. So if we did need to expand that, we still can go in and do so. So those are the main two things that needed to be done in this, which was the frame and then manipulating the actual seat itself. So just like with the other one, I now want to go through and complete my task. So I can go in and say I've updated it. I can go through and add the resulting objects to this, so that now that information will be shown here. And then once again, just simply go through and complete the task. Now, when I complete this task, as I mentioned before, there is a third task, which was creating assembly drawings. That is not assigned to me. That is assigned to John Hughes, who will actually be doing the next webinar in the series. So this webinar ends with me completing my two tasks, and John's will begin with him now starting with this third task of just creating some assembly drawings and some other objects from the manufacturing standpoint. So that's what we see here, is when I go back and I look at that change notice that had the three tasks, we can now see that the first two tasks, which was mount the car body to the rear frame, that's been resolved. The second one, update the driver's seat design, that's also been resolved. And now we're on the third one, which is now the creating of the assembly drawings. That is the next phase. So those are all done. And as I said, we're going to be kicking those off next. Now, what I also wanted to do was I wanted to test that seat and see how a person would fit in the seat. So what I did was now I went in and now started using Manikin to go through and show a person sitting in the seat. And then from the seat, I also, of course, they're in the car. And then from the car, I went in and now simply showed the car with a transparency outline so that we can actually see the car itself and where the seat is located inside of it. Any questions on anything that I have shown up to this point? I do want to also emphasize the items that were used in the demo. So the first one is change management. So we've used change management through change requests, which I received initially from Bill to go through and review the changes that were made. And then I created a change notice to now go through and create the assignments to go through and update the geometry based on what needed to be done from the change notice. I also used Creo View as a way of me going in and viewing the information from the change. Now, anybody can use Creo View. So anything that has a viewable inside of Windchill, just simply your publisher, they don't have to have Creo to actually view it. All I did was view this, but it does have measuring tools. We can go through and explode assemblies. We can hide items in assemblies. So it's a very useful tool, even for those that don't use Creo. I also use BOM Management through Creo, as well as using WT parts. So we went in and actually manipulated the structure. We did what was called a CAD-centric BOM update, which means the BOM was driven by the CAD but you also have the ability to have a part-centric bill of material, which now is driven by WT parts. And we can talk about those later, or once again, we have other webinars that discuss WT parts as well. We've also used Advanced Framework Extension. It is a very, very powerful tool to go in and do your structural engineering. So tubes, I-beams, L's, shapes, brackets, as well as all the different miter cuts and things that are necessary to go in and create your structural designs can be done in Advanced Framework Extension. We use it here to go in and create the framing for the back of the car design. We've also used, this actually should be freeform design. I apologize, I didn't update that. It should be freeform design, or which allows us to go through and basically freely go in and manipulate geometry. So we can create it, push, pull on surfaces. Instead of them being dimensionally driven, they're more aesthetically driven. And that once again gets us from the industrial design area, then it comes over into the mechanical design area, and we will go in and manipulate it in order to make sure that it can be thickened appropriately using multiple tools. I only use the offset for what I was doing here, but there's tons of tools that can be used to go through and analyze, the development of the surfaces. And then of course, the last part I just showed was the actual Manikin extension. There's two versions of it. There is a licensed version, and then there is basically a trial version of it. If you're just doing it to go in and visualize it, you can use just a trial version. It will not allow you to save that Manikin, but you can show it. But if you have the actual Manikin extension, then yes, you have full functionality, and you can go through and save it with the Manikin actually in the model, so anybody else can also view it as well. All right, once again, any questions on anything that we have addressed up to this point? And I do recommend, if you did not watch the first of the Digital Thread series, I do recommend doing that as well, because this is going to work kind of as a story. So we're starting with one and now building on this car design from different viewpoints. So different areas of your company will be touching this in multiple ways. So we can go through and actually show how things are built up from one design area to another. All right, if you do want to know more about any of the information, you can of course reach out to us. We have training classes on pretty much everything that PTC has to offer. So we have certified trainers. We can do virtual classes. We can do in-center classes. We can come on site to you, just depending upon, of course, COVID protocol. As things are loosening up, then on-site training, of course, is what a lot of companies would like to do. So we are available for that, or you can come to us for one of our in-center classes as well. If you do have any questions on anything that was covered here, please feel free to reach out to me at mwimberly@pdsvision.us. Also, you can reach sales@pdsvision.us. For this webinar, the previous webinar, and any other webinars that we have, you can definitely go to our website or to our YouTube channel to go through and view that. Our website will take you to our YouTube channel, or you can go into YouTube and search. Right now, you can still search for Boundary Systems and it'll come up, but we're in the process of transitioning that to PDSVISION. But if you're going to YouTube, you can still look up Boundary Systems, and it will bring you to our YouTube page, which has all of our webinars. This one will be up, the previous Digital Thread, and all the other webinars that we've done will also be available there as well. So if you have any questions on training schedules, what webinars are coming up next, visit our website, pdsvision.us, and there will be a listing there as well as training classes and anything else that you need. So thank you for your time today, and have a great remainder of the day. And once again, look out for part 3 of our digital thread coming up in May. And that will come from a manufacturing point of view. So once again, stay tuned. Thank you.